Okay. Trigonometry. We're going to hear some new words today that we haven't heard in math before. Okay, but that's okay. We can hear some new words next year as well as the year after. Let me give you sort of the basic. You don't have to write this down. Let's measure that angle. Why?
Triangles, the angles out to one another.
Okay. Right.
90 plus.
You should know that the sum of three angles in any triangle always adds to 180. And this little symbol here, this half square, means 90-degree angle. So if this is 90 and this is 30, these are 120 together. Well, this must add to 120 to get 180. So it's 60. That okay. How'd you find the missing side? How'd you get 6? No, that's area. That's area of a triangle. That has nothing to do with finding the missing side.
It's 5.
Why is it 5?
Because a squared plus b squared equals.
You have to use Pythagoras here. A squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse. So 3 squared plus 4 squared is equal to c squared. This is 9, this is 16. Add them together and we get 25 is equal to c squared. Therefore, c is equal to the square root of 25, which is 5. This is math that you should know. Okay. How would you find that? If you're confused, you should be, because you don't have the math right now to find that. When we get questions like this, we can't use the three angles add up to 180 degrees, because I'm not asked to find this angle. We can't use Pythagoras because I only know one side. So what do we use? Trigonometry. So trigonometry helps us answer questions like this. And trigonometry literally means triangle measurement. It's Greek. The literal translation of trigonometry is triangle measurement. And it allows us to find missing sides or angles in triangles. We're going to start with right triangles, but you can actually use trigonometry or just plain old trig for any triangle. Okay? Anytime you fly on a plane, okay, if the plane doesn't know how to use trigonometry,
you're not going to get very far. Because trigonometry is used to calculate distances. Okay? GPS. If nobody knew what trigonometry was, GPS would not exist. Okay? It's impossible. So it's an extremely important topic. Okay? And why triangles? Why are triangles so important? Because triangles are really considered the strongest type of shape.
Like imagine if you had something like this as opposed to something like this, and you put a lot of stress on this, okay? So like, let's say you had a beam there and a beam there.
This would be able to support more because it's stronger. This would collapse. Look above. Okay, all those beams reinforced with triangles. That's to make it stronger.
That's so that the roof does not collapse on us.
Okay, if those were all rectangles, if those triangles weren't there, it would be weaker. I'm not saying it would collapse, but it would be weaker.
What am I doing? Okay, oh, good. So to understand how to use trigonometry, and once we sort of get past
Learning some new words, trigonometry is just equation solving. Because you're finding missing angles and missing sides.
okay, but we're going to come up with a couple of new names for sides in a right triangle. So you can see here, let's look at this right triangle. It consists of three sides. A, little b,
And little c.
okay? It also consists of three angles. A, capital B, and capital C.
So when we refer to an angle in a triangle, we refer to it by a capital letter. When we refer to a side, we usually refer to it by a lowercase letter.
However, you could also call this side A, capital GC. This could also be called this. Little b could also be called from capital A to capital C. And little c could also be called capital A to capital B.
But we just use the lowercase letters.
And here, in any right triangle, there are two angles less than 90 degrees.
Remember what the name we give to those are. What do we call an angle that's less than 90 degrees?
Acute. So A and B are acute. Whereas C is a right angle.
Okay. Now, when you guys did Pythagoras, we called two of the sides legs, and we called the longest side we call the longest side in the right triangle. We don't remember that word.
Thank you, hypotenuse.
Okay. How did we find that? Like, how did we know which ones were the legs and which ones were the hypotenuse in the right triangle?
Wasn't the hypotenuse always the longitudinal?
Well, not necessarily.
It was
Like, what if I did this?
would it be like
Which one's the hypotenuse?
one of the
Okay, you're right. Why?
because it's It's across from the meridian.
Excellent. Yes. It's always across or opposite the right angle. Okay? So we're still going to use the word hypotenuse. Okay? But we're not going to use legs anymore. We're going to use two different words. And what words are we going to use? It all depends on what angle, acute angle, we're talking about. So if we're talking about this acute angle here, and we'll use different colors. Oh, that's it. We're talking about angle A. This is the hypotenuse because it's opposite the right side. So little c is going to be the hypotenuse. What side is opposite angle A? Like if I were to draw an arrow starting at angle A, what side would I hit? Little a. Okay? So we call that, because it's opposite the angle, we call it opposite. And the third side, which you can really just get by elimination, little b, is called the adjacent. Because it's beside angle A. Adjacent means beside. So if we're talking about angle A, little a is opposite. Little b is adjacent. Little b is adjacent. And little c is the hypotenuse. Okay. But what if I'm referring to angle B? That acute angle. What side is the hypotenuse? It's still this one. The hypotenuse is the longest side, or it's opposite the right angle. But what's the name of this one now? Opposite. Which means the third side by default must be adjacent. So you see, we use three words, opposite, adjacent, and hypotenuse. But the opposite and adjacent sides depend on which acute angle I'm talking about. Okay? So in this one, A is adjacent. B is opposite. And C is still the hypotenuse. So let's do a little, I'm going to call this capital X, capital Y, capital Z. So I'm going to call this one little x, little y, and little z. Okay, you don't have to write this down. This is just, tell me what side, little x, little y, little z, is opposite angle x. What side is opposite angle x? Little x. What side is adjacent to angle z?
X. Wait, is X.
Well, this is, hopefully you've all seen this as the hypotenuse. And for z, that's the opposite, that's adjacent. So the answer is also little x, you're right. Okay. What side is the hypotenuse? Little y. Okay. What side is opposite angle z? Little z. Because I draw an arrow out from here and I hit that side. Okay.
So you should be familiar with that.
Well. Let's put one over here. Trying to think of somebody in here I can use, Jenny, or Julie. M-A-O. So little o, little m, little a.
This is Julia's triangle. Okay. What side is adjacent to angle O? Little m. Good.
Because the opposite side is little o, the hypotenuse is little a, which means by default,
That must be little m. What side is opposite? No, sorry. What side's the hypotenuse? Little a. What side is opposite angle m? Little m. Okay. So we should be comfortable with that, how to name those sides, because that's an important part of setting up trig equations.
remember I said trig is all about equation solving? We gotta know those sides to set up the trig equations. So, in any right triangle, there are different ratios of side lengths. And identifying these ratios depend on what acute angle we're talking about.
So for example, and ratio is a comparison of two numbers.
So let's say I did, I'm actually going to put some numbers in here now. Six, 8, 10.
What is the ratio of the side opposite Z to the hypotenuse? What two numbers is that? 8, and then we would write over 10. So the ratio of the side opposite Z to the hypotenuse is 8 over 10. Okay? What is the ratio of the side opposite X to the side adjacent to X? 6 over 8. Excellent. Okay? All of those ratios have certain names, depending on which one we're talking about.
Notice the first one I asked you was opposite over
Hypotenuse. The next one I asked you was opposite over adjacent. There's actually 6 different ratios you could make up, and they all have different names. We're going to talk about 3 of them. Today, we're just going to talk about one of them.
So,
One ratio,
and it's the ratio of opposite side over adjacent side, has a special name. Okay? So one such ratio is the length of the side opposite to an acute angle to the length of the side adjacent.
and what do we call this ratio?
We call it the tangent ratio. Or just for short, tan.
So if we looked at that triangle at the top of the page on the previous page where we had capital A, capital B, capital C, and little a, little b, little c,
The tangent of angle A is the ratio of the side opposite angle A, which in that figure is little a. Because if you look back at that figure, the side opposite angle A is little a. To the side adjacent to angle A. Which was actually side little b. But we don't want to write all that. Okay? So for short, we would just write tan A equals little a over little b. Hopefully you have a graphing calculator with you. Graphing calculator, scientific. If you do, make sure your display, somewhere on your display there's a D or DEG. Because you have to be in the right mode. Well, let's just see if you're in mode. I want you to punch tan 27 equals 10, T-A-N, the 10 feet. 10, what? What's he talking about?
27.
10, 27 equals. Did you get about 0.5? Then you did it right, and your calculator's in the right mode. Did anybody not get that? Anybody need a hand? That's okay. Remember, we're just starting this.
10.
Yeah.
10 ways.
Swear, no. You were in a different mode. That's okay. That's, you always want to make sure the two of you have the same calculator. It should say DEG on your display. If it doesn't say DEG, you're going to get some weird answers. So what does that mean? What that means is that in any right triangle where one of the angles is 27 degrees, so if we have something that looks like this, the side opposite, because remember tan is opposite over adjacent, the side opposite divide the side adjacent must always work out to 0.5. Okay? So if I gave you, don't write this down. If I gave you 4 and 20, that triangle doesn't exist. Because if this is 27 degrees, this divide this side has to be around 0.5. Or in other words, this has to be half of this side. This triangle can't exist. But I said that triangle exists. Because this divide this is 0.5. Would this triangle exist? Yes. Would this triangle exist if I told you it was 27? No. So that's what it means. Okay? I want you to have just some idea of what it means before we just start calculating. So that means in any right triangle, the side opposite 27 degrees divides the side adjacent 27 degrees is about 0.5. Notice when we actually did it on the calculator, we got a whole bunch of decimal places. We just rounded it. Okay. That's sort of the basics. How do we do these questions? I am asked to find the tan of angle D and the tan of angle F. Well, remember, the tan of angle D is whatever the side opposite D divided by the side adjacent to D. What is that? What are those numbers? Yeah, do I do 3 over 4 or 4 over 3? 3 over 4, because it's opposite D, which is 3, over adjacent to D, which is 4. What's the tan of angle F? 4 over 3 would be the reverse, would be the opposite. And that's it. You're done.
So do we do like actually press the calculator to calculate it, or?
Well, not for these ones. Not for these ones. But what if I actually find the angle? Now you need your calculator. Okay. So we're going to start with this example. I'll fill this in later. Okay. Here we are asked to find the actual angle measures. Okay. Well, we used the trig tan to help us. Let's start with G. Look at your diagram. The tan of angle G is equal to what? What numbers? 4 over 5. What did we just create? An equation, right? And how do we solve equations? We need to get the unknown by itself. Okay? So we need to get G by itself by getting rid of this tan. Now you can't just divide tan, because this does not mean tan times G. How would you get rid of a square? If something was squared, how would you get rid of it? Square root. If something was multiplied, how would you get rid of it? Divide. If something was subtracted, how would you get rid of it? Add. You do what's called the inverse. You don't know what the inverse is, but actually to cancel out a tan, we use a little function called tan inverse. That's it. Now I know it looks like tan to the -1, but this reads tan inverse. And where do you find it on your calculator? You find it above the tan key. So you get to it by shift. So hang on 1 second. So remember, tan inverse and tan cancel each other out. But that means I got tan inverse this side. So that means G, you have to go shift tan on your calculator to get to tan inverse, and then punch in 4 divided by 5. And round your answer to 1 decimal place. Anybody want to take a shot?
Yeah, I thought 38. Round to 1 decimal.
38.7 should get out. Okay, no, it's 38.7. Well, this is a nice one. Because what you have to do is you have to do it in reverse. You have to go 4/5, and then you have to go shift 10 inverse. So, okay, shift second 10. You're gonna have to use open parentheses. 4/5. Okay. Okay. So you should get, nearest tenth is 1 decimal place. You should get 38.7 degrees. So we found angle G. Notice there's a big difference between tan G is just a fraction. G, we actually have to do the tan inverse. What would the equation look like to find H? Tan H equals what? 5/4. Wait a minute, tan G, I'm sorry, not H, tan G. Didn't mix. Yeah, 5/4. Sorry. Oh, that's why you guys don't want to answer, because you think I'm going to jump all over you, or you think your classmates are going to jump all over you. Just like when I made a mistake, you guys jumped all over me. Okay, I got to get G by itself. We're going to get rid of 10. How do I get rid of 10? Tan inverse. Boom. Whatever you do to one side of an equation, you got to do the exact same thing to the other side. So you do the tan inverse of 5/4, round your answer to 1 decimal place, and I'm thinking you're going to get 51. Whoa, hey, 51.3.
Yeah.
I didn't look at my notes. How did I know that? Because these two have to add up to 90. You see how it's all interconnected. Yeah.
Yeah.
Okay. Oh, sorry. I forgot to, so basically what to do. If we're given the measure of an acute angle, we can calculate its tangent using the calculator. If we know the tangent ratio, we find the actual angle using the calculator by working backwards using tan inverse. Or on your calculator, it's always going to be shift tan, because it's going to be above the, or second function tan. Okay? I love trig. I love trig. Okay, where's one area we can use it? Solar panels. You guys familiar with latitude and longitude? Okay. Or was that a nightmare that you prefer to forget? Come on. Is it? Why you, what? Yes? Now you were just itching to say something, Jen. You were just itching to say something to her. Like you fired your head over that way, like so fast. It caught my attention. What did you want to say to her? Now I'm curious. Now tell me. All right, fine. Okay. So latitude is how far above you are or below the equator. Okay. So we're like, I don't know what we are. 49, 50, 51 degrees or something like that. Okay, it's measured in degrees. So we're 51 degrees something above the equator in a cold area. That's where we, somewhere around. Okay. How do they put solar panels on houses? Or how did, like if you've ever seen solar panels in the field, do you notice that a lot of times they're angled? How do you know what angle to put them at? You use trig.
Okay? Because if you put them at the wrong angle, the sun is not going to maximize its effect on it, and you won't get as much energy. You want the sun to hit it at its maximum point to absorb, right? Like if you have the sun coming like this, and you're flat like that, it's not going to generate a ton of energy. But if the sun's coming like this and punching down energy like that, you want an angle to catch it flat on. Okay, so that's why we always want to angle them. And so what we do, if you want to put it on your house, say you want to put it on your roof, you got to know the latitude of where you live, and you got to know the angle of your house, or the angle of inclination of your roof. What does the angle of inclination mean? It means the angle between a horizontal segment angle formed between a horizontal segment and a slanted segment. So for example, the angle of inclination of a house roof, well, it's the segment of the slanted part of your roof and a horizontal segment. So that is the angle of inclination. Okay. If this angle matches the latitude of your location, you've maximized the placement of your solar panel. Okay, so a latitude refers to how far above or below the equator. So here's our example. We've got a place in the Northwest Territories in Fort Smith. Okay, and its latitude is about 60 degrees. These people put a solar panel on their roof. They want to know if it's the best fit for being in Fort Smith. So what do I have to find? I have to find this missing angle of inclination. So look at this triangle. This is 9 feet. This is 12 feet. This is a right angle. That's what I want to try and find. I don't know it yet. What do you want to call something if we don't know it? Hmm? Thank you. Call it X. Call it B. Call it M. Whatever you like, just call it a letter. So we're going to use 10. So we need to set up our equation. Can somebody take a shot at the equation? Well, what are we going to start with? Not X. Tan, that starts our equation. And then of the angle, right? Well, what's the angle in this case? X equals the side opposite angle X, which is what number? 9, over the side adjacent to angle X, which is 12. There's our equation. How do we solve for X? Well, to get rid of tan inverse, which means I got to tan inverse this. So that means X is going to be about what? Nearest degree, if you could do it on your calculator. Nearest degree, whole number.
37.
37 degrees? Is that a good fit? For the latitude of Fort Smith? What's the latitude of Fort Smith? 60. And yet it's put its solar panel at an angle of 37. Is that a good fit? No. Okay. No, it's too flat. I mean, it would still work, but it may just not work to the maximum efficiency. So, not a great fit. At 60-degree latitude. One more question. This one we're going to have to draw. Okay, I can't, I'm a lousy drawer, but I think I'm able to draw a wall and the ground and a ladder, which is what you're asked to do. A 10-foot ladder leans against the side of a building with the bottom of the ladder, its base, 4 feet from the wall. What angle to the nearest degree does the ladder make with the ground? Well, let's draw a ladder. It's leaning up against some wall. And we assume the ground is flat, and we assume the wall is vertical, so we assume it's a right angle. Can you see the right triangle in this problem? Okay. The ladder, the ground, part of the wall. Now, where does the 10 feet go? What side is the 10 feet? What?
On top of the ladder.
A 10-foot ladder. What side is 10 feet? The ladder is 10 feet. The ladder is 10 feet. Okay, but I need you to say it. I don't need you to. Like I can imagine you guys trying to get each other attention if you're far away from each other. Hey, I'm over here. Hey, jeez. Hypotenuse. I'm just saying. You guys are all, you're like, oh, oh. Okay, what side is 4 feet?
The ground.
The ground. I heard you the first time, but that's okay. Go ahead. It's this. What's the angle we're trying to find?
The wall.
The wall. The wall is a side, not an angle.
X.
I see no X in here. I'm asking you where to put the X. Is it here? Is it here? Is it here? The what?
The last one.
The last one.
No, but I thought it's all line.
That's a line. It's not an angle.
The angle, and where
The angle between, thank you. That's good. She used the numbers to describe it. The angle between 10 feet and 4 feet. 4 foot. Okay. Okay. We got the diagram done. Somebody want to give me the equation?
equals.
Yeah. You're almost there. Be confident. Stop staring at her.
10, 4 divided by 10, 10 divided by 10. 4 divided by 10. I think it's. How do we know which one's?
Nice. Nice. What side is up? I guess Candy's hurting. Like, would you settle down up there? Okay. What side is opposite angle X?
It's the unknown.
It's the unknown. But can I find it? Using what kind of math? A squared plus B squared equals C squared. So notice we've got to do a little bit of thinking here. You're on the right track. So we're going to use A squared plus B squared equals C squared. Well, remember, one of the unknowns here is A or B, right? C we know, it's the hypotenuse. So let's call this A. So A squared plus what? 4 squared equals 10 squared. A squared plus 16 is equal to 100. A squared is equal to 100 minus 16, which is 84. A is going to be the square root of 84. Let's go to one decimal place. 9.2. Anytime. So notice I couldn't use the trig function right away, or couldn't use the tan right away. I had to find the opposite side. Now we're ready. 9.2 over what? What side? Opposite over adjacent. 4. How am I going to find x? Tan inverse both sides. Tan inverse. And then when we do that, we're going to get our answer. What does it say? Nearest whole number. Yeah, nearest whole number. 57? 67? There we go. Okay. Which is an extremely unsafe angle. I think anything past 60 is considered unsafe. Okay? Otherwise, it's just going to fall over. That is the start of trig. What we do tomorrow is we learn how to use trig to find missing sides. Today we use trig to learn how to find missing angles. Tomorrow we use sides. And then after that we learn 2 more trig functions, 2 more trig names. Sin and cos on your calculator. They're beside tan. Yes.
I forgot like my.